Assalamualaikum warahmatullahi wabarakatuh. Let us continue. The first thing, what you should do before you watch this video, you should watch the YouTube of two-phase separator and three-phase separator, and what is inside it. For example, you when what is part of the weir, what is what else? Gas blow by, what is things like that. So what you should do actually is to take a note on that one. So which one is the one that important? And then we go to the design of separator. The basic theory is what we have is a droplet. In separator we have a droplet. We assume that everything is spherical. So oil droplet, spherical, in water means the continuous liquid fluid is water and there is oil in it, or the continuous one, water in oil, the continuous one is oil and we have water in it. Oil and gas, the continuous one is a gas, so we have oil in it to separate. So usually we have here a dP, droplet pressure, a droplet diameter. Okay, diameter of the droplet, dP. Retention time, when what is time that is needed for the droplet to be dispersed from the continuous phase. For example, that the time for the oil to be separated from the gas. The gas is the continuous one. So if I see on the definition from Schlumberger, the amount of time of liquid stay in a vessel, the retention time assures that the equilibrium between the liquid and gas has been reached at separator pressure. So this one is separated between liquid and a gas. And this is the retention time of retention time of a continuous fluid, of the droplet of dispersed fluid, dispersed phase. And the retention time in a separator is determined by dividing the liquid volume inside the vessel by liquid flow rate. The retention time usually varies between 30 seconds to 30 minutes. If it's a foaming crude is present, the retention time could be increased by 4 times its normal value. So that's why in the separator we don't want any foam. So you will be able to see the latest the sentences in the bottom later on if we do the exercise. And settling time, the time that when the time, so between the restant time, for the trap to be dispersed, and this is the real time, the settling between of the of the droplet to be separated from the continue. So this settling time Vt is the settling is not Vt. This depends on also on the track of the droplet of a gas phase. We'll talk about it later. If you want to see it, okay. I took from GPSA. So this is a liquid droplet, okay, this is the gravitational, this is called settling time, and then the VT, VT here, the settling time, has to be greater than the drag force to move, for the gas to move around. So this is called settling time, and this is the so this velocity of terminal velocity, this is the velocity where the settling time happen. Okay, so the VT, terminal velocity, VT is the settling time happen. It is gravity settling section, the liquid drop. So if you see the one settling section of liquid drop will settle at the velocity determined by equating the gravity force on the drop with the drag force caused by motion of relative of the gas continuous phase. Okay, so this is the terminal velocity is the velocity which settling time occur. Okay, settling time occur, gravity settling section, the liquid drop will settle at a velocity when equating the gravity force drop. So there is a question on it. So if you see on the GPSA, you see here, this is the equation of terminal fundamental velocity, and you see that there is a drag force here, which is C action. So for G, dp, and etc., this is just dp is the diameter, density liquid, density gas, and this is the density of gas, and Cg is a drag force. The drag force actually so we goes to the next one. So Phi is a function of drag force. Drag force is a function of Reynolds number, and Reynolds number is a function of Vt. It's a trial and error. But in GPSA, there is a simplified way to do that. So if you see on the GPSA, there is simplified way to do that. So by using the graph, this is equation of drag force multiplied by Reynolds number square, you will end up with having what is the value of drag force. Okay. Go back to here. But if you see, and then you will finally the Vt. What is the Vt actually? Is the velocity for that we needed for separating between phases, between two phases, between one phase to another. So this is from the Vt we will able to decide what is the length, what is the height of the separator. Okay, what is the diameter, what is the length, diameter and the length of separator. So Vt is the vital parameter to design the separator. This is the simplest way, but of course this is simplest way, but of course there is very detailed ways to design a separator. Okay, so I will make a homework on this based on page 711, and if you want more detail on the trial and error, you can see on the page 226, and and then you will find another page is another example for 1 and example for 3 on this surface production. production operation book. I will include this one on in the Google Scholar, Google Classroom. I'm sorry, Google Classroom. I will put this one. So please read this CPSV for page 7.1 to 7.11, and please understand this page 26 to 6 to for example 4.1 and sample 4.3.